Today we are going to look at the question remove covered intervals, Leetcode question number 1 to 88. So the question says we are given some intervals and we need to remove all intervals that are covered by another interval in the list. Now the explanation of the example won't be much efficient here, so let us quickly jump onto the blackboard and let's see what the question asks. Okay. So this is our question here. We are given three pairs 1, 4, 3, 6, 2, 8. On the x-axis, I have represented them with different colors. So 1, 4 comes under yellow, 3, 6 comes under green, 2, 8 comes under pink. Okay. Now the thing that we have to notice here is that 3, 6 comes directly under the umbrella of 2, 8, right? So this is what we are not going to consider. So the question says, if there is some interval which is directly under the umbrella of some other interval, so ignore that interval. So if we ignore 3, 6, we'll just be left with 1, 4 and 2, 8, right? So that is, we are left with two intervals. So our count will be 2 and this is what we have to return. This is the question. Now how do we solve this? Now how do we solve this? First of all, what I would like to do is, what if I sort these intervals? If I sort these intervals, then I'm going to get 1, 4, 2, 8 and 3, 6, right? The sorting is going to be done on the basis of the first number in the pair. So after the sorting, this is what we are gonna get. Okay. Now let's look at this same intervals again. And let's say we have a count here. Okay. Initially, let's say the count is 1 and we need two more variables. Let's say left and right. So left and right. What we'll do is, on the left we'll keep the values of the first pair. So we'll keep left as 1, right as 4. Now let us start iterating from this second pair onwards. So what we'll do is, let's say we come to 2, 8, right? We come to 2, 8. Now we'll check if my 2 is greater than left and 8 is greater than right. If it is so, we understand that this pair has to be included in our answer. Okay, so in this case our count will increase, right? Count will increase by 1. So what we are checking is, see, if 2 is greater than L and 8 is greater than I, let's look at the x-axis, what's happening. So you can see that this interval here, okay, does not come under any umbrella. It's independent, so we have to include this. So this is one logic that we are going to follow. Okay, now let's go to the next. Okay, now that we have increased our count, so our count is now going to be 2, right? Now let's go to 3, 6. Okay, and one more thing, after we have updated our count, so now that we have found an independent interval, now our left is going to be, okay, let me write it down here. Now our left is going to be 2. We need to update this again, right? Left is going to be 2 now and right is going to be 8. Now let's come to the last pair, 3, 6. We can see that 3 is, you can see that 3 is greater than L. Okay, well and good, but 6 is not greater than 8, right? This second statement is wrong here, so we can't increase this count. So yeah, what this means is, if we look at the x-axis, when we encounter such a case where 3 is greater than L but 6 is not greater than 8, or 3 is not, I mean, greater than L, greater than R, if this condition is not satisfied, it means that we have encountered an interval which doesn't come under the umbrella of any other interval. So we don't increase the count still remains 2, and this is the answer that we have to return. Okay, so from this example, you understand that every time we encounter an interval that follows this property. it is greater than left, greater than right, okay, both of these at the same time, then we increase our count by 1, and at the end we return our count. Now let us look at another example for some more clarification. Okay, now let us look at this example. So we are given 5 intervals here. Okay, so like earlier, first let us sort this. So once we sort, we'll have 1 4, then we'll have 2 8, right, then we'll have 2 9, 3 6. So this sorting is done on the basis of first element of the pair, and if the first elements are same, then on the basis of second elements of the pair. So this is how, if we have pairs in an interval, this is how those are sorted when we sort them. Okay, so now let us apply our earlier logic. Okay, so initially we'll say keep our count as 1. We'll start with the first pair, we'll keep the left as 1, we'll keep the right as 4. Okay, now we'll start iterating from the second pair onwards, right? We'll start iterating from this point onwards. So when we come to 2 8, we see that 2 is greater than 1, 2 is greater than, 1 second, our right is going to be 4 here. Okay, now when we come to the first pair, we see that our 2 is greater than L and 8 is greater than R, right? So what we do is we increase our count. Okay, increase our count, and our count becomes 2. It means we have encountered an interval which is independent and does not come under any other umbrella, so we include this. Okay, well and good. So 2 comma 8 is done. Now let's go to the next pair, that is 2 comma 9. And one more thing, when we have updated our count, we also need to update left and right, correct? So our left is going to be now 2, right is going to be 8. Now we have come to 2 and 9. We see that now 2 is greater than left is not right here, but 9 is greater than right. So if you see, this condition does not hold here, right? Because left is 2 and now we cannot say that 2 is greater than 2. So this condition is not right here. We can't increase our count. So what does this situation mean? This situation means that, see, even though we have sorted the intervals, right, on the basis of first element, but what happens when you encounter such a case where the first elements of the pairs are same? It means that even though for 2 comma 8 we have incremented our count, right? So 2 comma, on the x-axis if you see, 2 comma 8 is this part here. Even though we have incremented our count, but we see that the next pair that comes is 2 comma 9. Okay, so actually we should have considered the pair 2 comma 9 instead of 2 comma 8, isn't it? So when we for that reason, when we encounter such a case, okay, where 2 comma 9 should be considered instead of 2 comma 8, what you do is, if we encounter such a case, then we wouldn't increment the count, but we'll increment our left and right. Now even though I said increment our left and right, now you can see that left is going to be the same in both these cases, right? So we just have to increment our right in such a case. So what we'll do is, now our right is going to become 9, right? Right is going to become 9. See, this is a case where even though we are not incrementing the count value, but our right is going to shift. So that's the whole logic here. So our code is going to be pretty simple. Okay, we just need to check a couple of things here. If this condition satisfies, well and good. If this condition satisfies, we increment our count and then update the values of left and right. But if this condition does not satisfy, okay, if this condition does not satisfy, then we won't increment the count, okay, we won't increment the count, but we'll just update the values of right, not left. Left won't be needed because, like you can see, we have seen this case here, right? All these elements will be sorted already. Only there might be cases where the first element of the pairs might be same, so we won't need to update the left in such a case. We'll just update the right. Okay, so now let us look at the working code, and it will be much more clearer, I think, from the code. Okay, so let's see how to code this. So we'll do exactly what we have just discussed. At first, when we are given the intervals, the first thing we need to do is we sort out these intervals, right? So how do we sort? We sort like this. Sorry, should be single t. Okay, so intervals dot begin. Just use our standard sort function and sort our list of intervals. Okay, now once the sorting is done, I need three variables now. One is our count, that will keep the answer. Okay, let's say initially it is 0. Can keep it 0, and we need two more variables. Let's say left, denoted by L. Let's give it int min initially. You will understand why I'm giving it int min now. And let's say right, let's give it int min as well. Now let's start iterating the interval list that is given. So one way to iterate it using our auto here. Okay, so what it does is, let's say, so this is actually a way of iterating the intervals here. So as you can see, we are given this list here, right? So in this, the v that I have declared here, this v will actually be now a vector of two elements. Okay, so if you say v0, it is going to be the first element here, 1. Okay, if you say v1, it is going to be the second element here, 4. So this is how it works. Now our job becomes pretty much easier. Now that we know how to iterate the interval, we just need to check one thing here. If so, this v is going to be a particular interval every time, right? So for the first time it is going to be 1 4, for the second time it is going to be 3 6, for the third time it is going to be 2 8. So for each of these intervals, we have to check whether our v0 is greater than left, that is the first element is greater than left, and our second element is greater than right, r, right? If it is the case, then we increment our count, right? And we change the values of left and right. So left is going to be v0 in this case. And now comes the tricky part. Now I'm not going to change the value of right inside this if condition here. We'll see why. What I'm going to do is I'm going to change the value of right outside the if condition, and I'm going to say max of the previous right and current view. Okay, and then we are going to return our count. Now my question is, or the question that should come to your mind right now is, why this updation of r variable in line number 11 and why not inside if condition? Now remember the scenario where I said if we have cases like, let me write it down here itself. If we have cases like we have one pair is 2,8 and the other pair is 2,9, what do we do in such a case? In such a case, we don't update the count, right? We don't update the count, we just update the right. So if I have written the updation of r in line number 11 actually for that reason only. If we encounter such a case, then our if condition is obviously not going to run, right? v0 greater than l won't be correct, so this if condition won't write. won't run. So, but you still need to update your R, right? So this is the reason why R is outside the if condition, because even if condition runs, you can still update the right here, and even if it does not run, the R is still going to be updated. So that is why. To take an example, use pen and paper. This should be, I mean, it will get clear to you if it is not yet. So let's submit and see if it works. It should work. Let's see. Yes, you can see it has worked. Yep. So this is how this question is solved. Thanks for watching.